Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Bring your data to life by graphing it on Streamlit. Create interactive graphs in minutes with Streamlit. So, why am I talking about graphs all of a sudden? The primary reason is the I have been doing a lot of discussion on large language models. If you have been following up with my various videos, you must have already seen that. And recently, I have been discussing more about knowledge graphs and discussing about ways to use knowledge graph related databases like Neo4j. So if you visit this particular playlist, then you will actually get to understand a lot of open source models that is available in Hugging Face that you can actually download and start using it for yourself. And I also discuss about various other open source libraries. Among them, Neo4j is one of the libraries that I recently covered, and I spoke about knowledge graphs in detail. When I was trying to wrap my mind around this concept of knowledge graph, I realized that without Neo4j, without using Neo4j, just by using Python constructs, meaning just by using lists, dictionaries, and data frames, that is pandas data frames in Python, we can actually create such kind of graphs that you see in Neo4j. So to just show you an example, so this is a kind of a graph that I have created based on Indian companies and their management. So when I say management, I'm talking about their chairmans and their vice chairmans, their board especially. So here you see it's actually empty. It doesn't look as if it has got anything to do with the board. But if you scroll on, if you go on top of the nodes, so this is called as a node, and this is another one node. This is the organization, and this is the person or the board member, and the board member is connected to the organization. So this is kind of a graph that you can create, and this is a directed graph, and it has got two nodes with an edge. So this particular arrow mark you see here, which is light, but that is called as an edge. So I delve deep into these concepts in my earlier videos on Neo4j. However, what we are going to do here is this particular interface that you are seeing, it is actually available for you. You can actually, I'll be giving you the link for this this particular graph, which you can play around. The link will be shared with you guys in the description. You can take a look at that. And as you can, if I scroll back a bit, and if I scroll in here, you can see a kind of relation. So there is a company called Aarti Drugs, and there is Aarti Industries, and there is kind of a these nodes are actually attached together. So there is some kind of relation between Aarti Drugs and Aarti Industries, and the relation is through these Mr. Chandrakant, Mr. Rahesh, Mr. Bhavesh, and Miss Preeti. So these board members are there on the board of both the companies, and we can visualize this using graph directly, and we can do this using Streamlit. You don't need to work on Neo4j. The point I want to make here is that when you see graphs in the wild, it can be intimidating. So what I mean by intimidating, let me show you something else. Now you see this graph has this graph is created from the comments that has been posted on my own YouTube videos, and so here you see the graph is made of 1 2 3 4 total 7 nodes. Now I'm going to play with this slider here, and I'm going to increase it to 12. So I'm going to bring in all the data that I've got that is available inside this particular data, and you see the number of nodes have increased, and immediately you see the complexity feels it's actually becoming more. Assume now, instead of actually having only maximum of 20 nodes, what if there is 200 nodes? How can you try to visualize this, and how can you actually make something out of that graph? So we are going to take a look at that aspect of visualizing the data in the form of graph, and trying to find the connections, and creating communities, working around the graph data structure. Let me go back to the earlier discussion that I was having. So here I am talking about 5 different companies here. So this particular interface that I'm giving only allows you to update only 5 companies. So it does not allow you to go more than 5 companies, because as I was telling you, it becomes difficult if there are more data in the graph. So it becomes little, it becomes a challenge to comprehend what is going on. So now you can see that, let me actually remove this Aarti Industries and let me bring something which is not related. So let us go for Apollo Hospitals. So sometimes when you are going through all this and trying to visualize the various companies, you will be surprised to find that 2 completely different companies or organizations might have a connection. And when you are going to bring all those connections together, so that is when you can actually find very interesting behavior in the network. Network analysis and network topology, ontology discussion. I'm not going to go into that aspect of graph networks and graph algorithms in this discussion, but this could be a starting point for you guys to get inspired and move forward. So this is an example that I want to share with you guys what exactly we are going to do, and I'll be showing you how to build these kinds of graphs. So at least I'll be showing you this graph, how it is being built, and you'll be really surprised how simple it is. Now what we are going to do is we are going to go to this particular repo. This particular repo is already public and you can actually take a look at that. This repo contains the necessary code as well as the necessary data for you guys to work with. So if you go to the code script notebooks and if you go into the Python scripts, you will find 2 folders. One is JSON reader and another is company management. We will be working with company management folder, and this folder contains the application. And if you click on the application, so I'm going to directly dive into the application, how it is being built. So this is the code, right? And the raw data of this code or the CSV file is available in this location. So it is also available in the GitHub repo only. So let us go back to the presentation. So what is the problem actually? We have to always think about the problem that you are solving. So I showed you how visualizing the graph can be done, and I showed you some examples. But the problem really when it comes to visualizing graph is to actually create the graph. If you are working in Python, there is a couple of libraries like PyGraphViz, there is NetworkX, and a couple of other libraries also you might be knowing. But these libraries don't give that much amount of, you can even use Plotly. So I have been experimenting with all these libraries, exploring it. The challenge is creating graphs and visualizing them inside that environment like PyGraphViz and Plotly, etc. takes a lot of code. On the contrary, Streamlit makes it extremely easy. So, and why it is becoming easy? Because there is something called a Streamlit Agraph. So this was one of the plugins, I should say one of the additional components of Streamlit library that was created by Christian Claus. So huge shout out to Christian Claus, and you can find out about him more on github.com, his link here. This particular Agraph allows us to use regular Python dictionaries, lists, converts them to nodes and edges, and then helps us to visualize it through Streamlit. So all these things are possible because of Streamlit Agraph. All you need to do is pip install Agraph, Streamlit Agraph, and you will be able to start working on that. And if you want a data science alternate, as I already told, there is Neo4j. And Neo4j also I have covered it in a separate discussion. So what we are going to do is, you can actually take a look at Streamlit API reference. If you are new to Streamlit as a whole, then I would suggest that you guys take a look at my earlier videos on Streamlit and also on the Python ecosystem as a whole. The reason why I am covering this, as I already told, is because of my interest in creating knowledge graphs and also finding out different ways to solve a problem. And the problem is here to creating graphs and displaying graphs and interacting with it. So these are the 3 problems Streamlit solves very easily. So how it happens? So you start by creating nodes, and you start by creating edges, and then you place it on the graph. And all these things can be done without much of an issue with Streamlit Agraph. I'll be showing you how to do that. And I'm not going to dive into how Streamlit Agraph by itself is implemented. So that is, it involves multiple, both front end and back end, because, okay, as I was telling, I'm not going to dive into it. Do take a look at the GitHub repo and you will be able to find it out. The graph that you are going to create is going to be Python objects. And these Python objects, the nodes, the edges, etc., can have its own attributes. It can have its own parameters, methods, etc., which you can use for interacting with it. And Agraph also provides multiple ways of creating physics simulations inside the graph. So let me go back to the browser, and you might be a little bit astonished to see how the graph actually moves around. And this graph is not, these nodes are not moving around freely. It is actually staying in place, while this particular node, if I am trying to move, they are actually very fluid. They are moving around the display. So this particular graph has been configured in such a way that it can have physics related algorithm already programmed into this. You actually don't need to worry about what algorithm is being run inside and how the nodes are getting centered. All these things are taken care by the internal algorithm that has been already written by Christian Claus. So, and also, if you take a look at this, here there is some way of filtering the organization. So, for an example, I remove a couple of organization. So I just remove this, and you see that immediately I get a list of organization I can select from, and then I will get a new graph altogether. Also, I can give it a moment as it gets populated. So you can see that City Union Bank, Anupam Rasa India, Apollo Hospitals, Deepak Nitrite. And if I click on show position, the position actually comes up. So what is the position here? So the position is the role, in this case, in Kamakodi. Mr. N. Kamakodi is the managing director and CEO of City Union Bank. So you see, this is the kind of relation that gets actually updated if you click on show position. So like this entire interaction, the way I'm interacting here, has been created by Streamlit. It's not created by this graph environment or Agraph, Streamlit Agraph. This has been created by Streamlit, and this Streamlit data actually gets integrated with the Streamlit Agraph. So it's kind of a mix and match of things, and you can get the things done really fast once you understand what is going on. So this is what I want to make you guys understand in the backend. So Streamlit is one of the tools that is available for such activities. There are various other tools like Chainlit, there is Gradio, and even in fact Streamlit is not just limited to regular Python data structures. It can actually work with machine learning models also. I'll be trying to work with Gradio, Hugging Faces Gradio next, and I'll be trying to introduce how you can work with large language models. Not large language models as such. I'll be working with language models like classification models and regression models, and let you know how to work with Gradio, and also how you can integrate Streamlit also. I'll be trying to discuss in that next video. So stay tuned for that. I believe that you like this content. Do leave a like and subscribe to my channel for further updates on similar kind of videos. So now let me go back to the browser. So the next thing what we are going to do is we are going to look at how we are going to create nodes, and how are we going to implement interactions using kind of interaction filtering options using Streamlit, and also how we are going to deploy it. So all these things we will be covering it in a couple of minutes. So let us go to the browser again. So the code that I'll be sharing it directly in the browser itself, in the GitHub repo that I already have hosted the hosted the code. So let me zoom in a bit so that you guys can see it better. To begin with, first of all, you need to do a pip install Streamlit -agraph. So that is how you get the Streamlit agraph library, and you import Streamlit agraph using this line. So from Streamlit agraph, you are going to get agraph. This is the main interface for getting the graph displayed in the front end, and the node, edge, and config is at the back end. So you will be seeing how this gets done, and I'll be also showing you a couple of ways to understand and make the life easier when you're going to build the graphs. So when you immediately think about graphs, you always think that, okay, how am I going to create these relations? It looks actually very complicated, but actually it's not. So if you look at this, just forget about these arrow marks for some time. All you need to do is ensure that you can place these nodes, all the nodes first. Okay, and once you're able to place the nodes, the second thing is you need to create edges that are going to work between the source node and the target node. So the edges are going to start from somewhere and end somewhere, and you need to write loops, basically for loops, that will create such kind of edges, and it will actually register it to the actual graph. This is all we are going to do, and that is how simple it is. And before I started, I did not know about that, but once I understood the actual algorithm and how it is being done, yeah, after that, yes, it is pretty simple. So this particular okay, in Streamlit, if you see, once I let me go here, and if I refresh the screen, I'm just refreshing the screen, and you see that immediately that this particular application has vanished. It's not able to load. That is because it's actually reloading the entire script. So it takes the script from this location. This is the exact script that runs this particular application. It takes the script from GitHub repo, and it starts bringing up the environment. Background Streamlit gives a Docker environment, if I'm not wrong. And in that environment, you see it actually gives a lot of such errors. Don't worry about that. Give it some time, it will finally give you this kind of a graph output. What is happening here is that the Streamlit is taking its time to load the data. So the data is getting loaded from this particular location, and it is going to be loaded only once. Okay, so if I go and change, sorry, I'm going to close this for a moment. If I go and change this, if I go and change this particular show position in the regular Streamlit application, what will happen is the entire data will get downloaded again to Streamlit, and then it will be populated into the graph. But since I used st.catch data decorator, since I use this, and I am going to load the data using the pd.read CSV, what happens is this particular data frame, whichever is returned from this particular function, is stored in the cache. So the cache of the web browser. So it is stored there. It is pickled into deserialized format, and then it is stored along with this particular URL. So whenever this particular application calls this particular function, it actually goes and fetches the cached data. So you are not going to lose unwanted time with that. And similarly, the same kind of decorator is available for cache resource also. So that you can use it for storing the models. If you're working with large language models, or in fact working with regular models, AI models, then you can use cache resource. I'll be discussing that in the next video. I'm calling this particular data frame, calling this particular function, and then what happens is okay, so let me actually show you how this data looks, so that you guys can understand what is going on here. Most of the time in my discussion, I always try to work with the data in a visible fashion. So what will happen is, once you look at the data, right? So like when you're going to be able to look at the data, the column names, and how the ID, the name of the person, the position he is holding, or the designation, and the company is working. So it all, you can see it here. So you can also download it and see that. And what I'm basically doing is, I'm reading this entire link as a CSV file and converting it to data frame. and I am getting the unique names of various board members, and I'm getting the unique company names also. So if you take a look at this names, there will be multiple repetitions, because there are people who are, as I already told, as you already saw, there are people who are board members of multiple companies. So like we have Chandrakant, Mr. V. Gogri, we have Mr. C. Gogri, we have Mr. Bhavesh, and we have Miss Preeti. So all this will repeat. So we have to first of all get the unique names, and we have to get the unique companies. So that is directly done using data frame, pandas data frames. And then this particular line is going to create this sidebar. Let me close this. So it is going to create this sidebar, and the sidebar is going to help us to do the filtering. So that is why I've named it as filters. And the write method is going to write the string whichever we give it to the these objects. So Streamlit is purely an abstraction on top of both front end and back end setup. So what happens is, if you want to really develop something like Streamlit, you need to have two things. You have to have front end and you need to have back end. So back end will provide the data, and front end you will have to create the HTML, you have to create the tables and the tabs and all those stuff. But here what happens is, all this thing has been taken care by the Streamlit itself, and all you need to do is use Python to fill up the data. So you don't need to worry about front end and back end. So this is the benefit. And all these things are done by creating objects, Python objects, and Python objects can be interacted using the methods and attributes. So you see there will be lots of methods, and all these methods you can actually find the application using Streamlit documentation. You can do a search of Streamlit documentation, you will be able to find it out. It's pretty straightforward once you understand what you want to do. So for an example, what happens is, before I even start working on this project, I visualize, okay, I want to create a graph, or I want to create a visualization, data visualization, which is filled with nodes of companies and organization, which shows the position of the board directors. So this is what I visualize, and then I come to Python and I start searching the processes or libraries that can help me do this, and that is how the entire thing starts. And so now I know how to create the visualization. Then I realize, okay, I need to create filters. So then I think, okay, what kind of filters I want to place? I want to place single value filter, or I want to have multi-select filters. Do I want to have checkbox? Do I want to have radio buttons? So all these choices can be thought of, and once you go to Streamlit, you will find the necessary methods and components that you can use. So it is as simple as visualizing something and going to the particular marketplace and buying it and using it. So it is like that. And here in this case, I have used the multi-select. So this particular multi-select option that you are seeing here is done using this. So here I have given select args as the label. So unique args comes from this particular list. So df.company.unique provides me a list of companies, and max selection I have I have constrained it to 5 companies, so it will not be more than 5. And here I am by default selecting the first 5 companies to show. So in that way, if I don't select this, what will happen is, once the graph gets loaded, it will be empty and it will create an error. It will throw an error. So it will not look good if you are going to present this to someone like you, right? So it's better to have something default. Next, as we proceed further, I want to filter it on the organization. So I have the various, so this particular line is going to give me a list of 5 organizations. And then I use something called as df company.isin. So this is a method inside pandas. So as you already see, I have been moving between Streamlit, Agraph, pandas. So all these are various Python ecosystem libraries which are all open source and all have one thing in common. They all work on Python objects and all have another thing in common, that is all the objects have methods with which you can interface and get the things done. So only thing all you need to remember is what you want to exactly get out of all this. So once you understand that, it is pretty simple. You will have lots of tutorials, lots of documentation, examples available all over the internet. Once you know what you want to solve, and you already have ChatGPT, so I don't need to even tell you. So if you go and ask ChatGPT how to create a graph using Streamlit, it is going to give you the entire code. Only thing that I want you guys to realize here is that once the code is provided from ChatGPT, you should be able to understand what the code does. So that is one of the key points that I want to help you guys with. So it's not that I am trying to make this for helping you to code. It's always you can go to ChatGPT and get it. Only thing I am trying to tell you here is that how to work with ChatGPT, how to work with various other open source models that can create code, and know whether the code is right or wrong, and how to debug it. So these are the things that you need to be aware of. And then, so let me continue with this code discussion. So once the filtered data frame is available to me, I convert this data frame into dictionary. So this is the first step. So why I convert this to dictionary is, it is very easy for me to work with dictionary instead of data frames when it comes to looping over the data. So once I move it to JSON to dictionary, then this will create me a list of dictionaries, and I can use that list of dictionaries. So here I am sending this dict_convert list of dictionaries here, and I am going to loop over this list of dictionaries. And this list of dictionaries, what it will have is, so it will, if I go back and open this, the funny part is you can actually, so if you are going to practice this particular code, you can download this code, execute it in your own environment, and you can put print statements. You have to put st.write. So if you are using Streamlit run, and if you are going to give this particular script name, so it is going to open it in a different browser like this. And if you want to print anything, you should always use st.write. So that is why you see everywhere, wherever I want to print something, the strings, I use st.write or sidebar.write. In that way, I can make it to print to the actual browser itself. If you are going to use st.print, it is going to print it onto your console, that is your terminal. So keep that in mind. That is one of the points that I wanted to highlight. Here you will see that I am connecting to the name. So I am looping over dict_convert, and this dict will contain all this data, but in the dictionary format. So how the format will look? So it will have ID, it will have the list index 0, and inside the list index 0, I will have all these names. So from 1, Mr. Bharat D. Shah and his position chairman, and the company that he works, 3M India. So data 0, that is, if I take a look at the data 0, it will be index, data 1 will be the name, data 2 will be the position, and data 3 will be the organization. So that is how I am getting this indexes. And then this is where the fun starts. So here you see, all I need to do for creating the node is to send an ID. The ID is the name of the person. In this case, I am creating a board member node. And then the symbol type, I'm giving it as diamond. So anyway, here it has not taken it up as diamond. It is still circle. And the color that I'm using. So here I'm using yellow for the people. Okay, and green for the organizations. So that is how I'm changing it. And in the same way, inside the orgs, I am trying to check, I am creating a separate node, and you see that is how it's getting created. And also you will see something I'm checking here. So I'm saying if org not in orgs. So why am I doing this? The reason I am doing this is, so internally to this particular function, I don't want to create multiple nodes of same organization. So there are various ways to work around this problem, but the solution that I chose is I continuously check the new organization that is coming in, and if the organization is already created, the node is already created, then I don't create it. And that is how I check it out. And if the node is getting created for a new organization, then I append the new organization to this particular orgs. And the same way I do this for executives also. So that is how I ensure that I don't have any repeating organizations or repeating people, repeating board members in my graph. It's that simple, right? So whenever you take a look at these graphs and you think about the nodes, and you always, I at least was confused that how people can really understand to create nodes without repetition. So it is as simple as and if you go and ask ChatGPT, I'm pretty sure it's going to give you the same answer. The point here is that you should first of all know that you don't want repetitive nodes, right? So that is something that I want you guys to understand. And finally, we have position. That is data 2 is the position of chairman, position of non-executive director, etc. And here I am using something called as position underscore show. So if it is, by default, it is false. And if it is false, it will not show the position. So here, if this show position is false, it will not show the position. So if I click this, it will show the position of each of the board members with respect to the particular company. So it takes a couple of minutes because it's open, it's a community server that I'm using in Streamlit. And yeah, so this is what I was talking about. So now it's saying managing director of. So Mr. Ramesh Ramadurai is the managing director of 3M India. And okay, by the way, this particular data has been taken quite a while back, almost a year back. So the data that you see here is not live, or it's not fresh. So don't worry, don't think that okay, all the data you find here is perfect. So keep that in mind. And also this particular data has been scraped out of the internet, so it's not available anywhere. So but yeah, this particular data you can use it, so no issues about that. And let us continue. So you see how the nodes got created, and finally we have the edge. So edge is going to be just the source and the target. And here also all you need to do is, in case of creating an edge, you don't need to worry about the duplication, because after all, the edges are there with multiple nodes and multiple sources and multiple organizations. So even if it is going to be with multiple sources and organization, the nodes are not repeating. So edges by default will go and start with the respective names and the respective organization. So this is also one of the aspects of Streamlit Agraph. So it is already programmed inside the edge class. So that's how it is able to do this. So I'm not going to discuss those points, but I want you guys to think in that route. So after I create the edges and the nodes, then I configure the graph. So this is the configuration I provide, where I can tell that what is the height and the width of this graph location. So height and width is, so what I'm trying to say, so this is the height, so this is the width, and so you see this is the width, so you see the width and you see the height here. So this is something that you can control using the config. You can use directed as true, physics as true, and hierarchy as true or false. You can work around these things. You can practice to see what happens. You can see highlight color to true and see how the behavior is, and you can work on the label properties. These are not the only configuration that you can do. There is a lot more to this. If you take a look at the Streamlit graph, Agraph library, you will understand a little more. And this is the checkbox that you see here, that you find here. And finally, I am creating the nodes and I am sending it to the Agraph. And once I give this particular line, return value equal to Agraph, and by default, Streamlit will know that okay, my script has completed and I have to actually display the graph in the front end. So that is how simple, that is how easy it is to create graphs and using nodes and various data from CSV file. And so here we saw a lot of things. We understood how the nodes are created, how the edges are formed, how the configuration between the interaction has been done, and how Streamlit can help in all these aspects. and what are the various components that is available in Streamlit that you can use for interaction. We saw all these aspects of creating interactive visualization, and I believe that you learned a thing or two from this discussion. So do leave a like and subscribe to my channel for further discussion on not just artificial intelligence models. As I was discussing in the earlier, most of the discussion surrounds the open source ecosystem. So I am a deep big believer in sharing knowledge, so I cover most of the open source related technologies as well as libraries. And with that said, I would like to come to the close of this discussion with 4 words, that is practice, 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 practice. See you guys, have a great time.